That is 4 unique groups. This carbon, number 4, is a stereocenter. Welcome, OChemNinjas. Assigning the label to an R or S stereocenter can be a historically confusing concept for students. The first thing we need to do is find all of the stereocenters in a molecule. In order to assign a stereocenter R or S, you'll need to see wedges and dashes on those carbons, so starting with carbons that have wedges and dashes is a good place to start. But not every carbon that has a wedge and a dash notation must be a stereocenter. Recall, sp3 hybridized carbon is tetrahedral. 2 of the groups are in the plane, 1 is coming towards you and 1 is going away from you. So we can use wedges and dashes to show things going away from you or towards you, even if they're not really a stereocenter. For now, at this beginning phase of our organic chemistry journey, a stereocenter we're going to define as any sp3 hybridized carbon with 4 unique groups attached. Extending that definition to more advanced topics is beyond the scope of this video. I do want to emphasize it needs to be attached to 4 unique groups, not 4 unique atoms. Each atom attached to the carbon does not have to be different. You can have the same atoms, but the group, the extended group, the functional group, must be unique on all 4 positions for that carbon to be a stereocenter. If we look at carbon number 1 is not a stereocenter. It's a carbon attached to carbon number 2 and 3 hydrogens. Those 3 hydrogens are all equivalent, they're all identical, they are not unique, so this carbon number 1 is not attached to 4 unique groups, so carbon number 1 is not a stereocenter. Carbon number 2 is also not going to be a stereocenter. Do you see why? Carbon number 2 is attached to an implied hydrogen and 3 carbons. That's not the problem. You can be attached to 3 carbons and still be a stereocenter if those 3 carbon chains are unique and different groups. For carbon number 2, the carbon 3 chain is unique and different, but carbon number 2 is attached to carbon number 1, a CH3 group, and this wedge group, which is also a CH3 group. Carbon number 2 is attached to 2 identical CH3 groups. Because they are not unique groups, carbon number 2 is not a stereocenter. Carbon number 3 is attached to the carbon number 4 group, which is unique from the carbon number 2 group, but it's also attached to 2 implied hydrogens. Those 2 implied hydrogens are identical, they are not unique, so carbon number 3 is also not a stereocenter. Most of the carbon atoms in a structure will not end up being stereocenters. In fact, most of the time, your instructor will only show wedges and dashes on things that are stereocenters so as not to be confusing. I'm doing it in this example so we really understand what it means to be a stereocenter. If you are asked to assign R and S labels, then any CH2 group, any methyl group, and any atom that doesn't have a wedge or a dash attached to it is almost certainly not a stereocenter. Carbon number 4 is attached to bromine, oxygen, carbon number 3 chain, and a hydrogen. That is 4 unique groups. This carbon, number 4, is a stereocenter. This is our first stereocenter in the molecule. Oxygen is not a stereocenter. For our definition for right now, it's not a carbon, but it also has 2 identical lone pairs attached, so it wouldn't be a stereocenter even if we were expanding this definition. Carbon number 6 is attached to the oxygen chain, which is unique from the hydrogen, which is unique from the 2 carbon chain, but it's also attached to another 2 carbon chain. There are 2 identical ethyl groups, 2 carbon chains attached to carbon 6. Carbon 6 is also a distractor. It is not a stereocenter, even though it has a wedge notation. There's nothing wrong with it having a wedge notation. The hydrogen is on a dash pointed away from you, but that doesn't necessarily make it a stereocenter. The 2 identical ethyl groups, in fact, tell us it is not a stereocenter. Carbon number 7 is a CH2 group. Carbon number 8 is a CH3 group. Both of those are not stereocenters. The only stereocenter in this entire molecule is carbon number 4. Let's go back to a fairly straightforward example. We need to find the stereocenters. Carbon number 1 and carbon number 4 are both CH3 groups. Carbon number 3 is a CH2 group. We can rule those out immediately, but let's look at carbon number 2. Carbon number 2 is attached to the oxygen. Carbon number 1, which is a 1 carbon chain. Carbon number 3, which is a 2 carbon chain, so they are unique. And a hydrogen, which is also unique. So yes, this is attached to 4 unique groups. Carbon number 2 is a stereocenter. Take a second, pause the video, see if you can assign the priorities to the stereocenters in this molecule. This molecule only has 1 stereocenter, carbon number 2. Cyclic molecules are not treated any different than acyclic molecules. So go ahead, pause the video, see if you can find all the stereocenters in this molecule. This molecule only has the 1 stereocenter. Carbon number 2 is not a stereocenter because it has 2 identical methyl groups attached. Only carbon number 6 is a stereocenter.
Thanks for watching. The best way you can support this channel is to let your friends know about these videos, especially ones who go to different schools. Help spread the word around the country. As always, don't forget to like and subscribe.